Hello everyone, my name is Greg and I dev stuff. Welcome everyone to episode 2 of Vampire Survivors like game in Unity. In this episode we will deal with an infinitely scrolling location. In the game, if you continuously walk into one direction, the level will keep repeating itself. I made the sprites in the paint net by using the free tile set from OpenGameArt. You can get this tile set if you follow the link provided in the description, and you can get these pictures too. Same place, description, just different link. So I draw two sprites, which will be our base texture for the terrain or background. Once again, you can download them through the link in the description. Then import overworld and objects into the game from the free asset pack, or any other collection of sprites of objects you will be using for your game. After importing those sprites into the game, we need to set up the sprites properly. If I put the terrain 1 on the scene, it will be ridiculously small in comparison to the player character. To fix this, we need to set the count of pixels per one unit of distance in Unity. Select the terrain 1 sprite in the project. The pixel per unit should be of the size of one tile your sprite sheet. So in our case it should be 16 by 16. But because our character is already set to be 32, it might make sense to select 32 instead of 16 on our terrain. In this case I will set it to 16, but because of this, the scale and amount of used pixels per character will not look the same and will be jarring. In your project, you want to stay consistent across all the sprites you are making, but because we are using free sprites, we had to give some leeway in implementation. Then you want to disable filtering by setting filter to point no filter and disable compression. This will make it so your sprite on the scene will not look blurry because of filtering. Repeat those steps for all the sprite sheets in your project. This episode is brought to you by generous support of people on Patreon and members on YouTube. If you want to join them, link to my Patreon in the description, and join button available right now on YouTube. If you join at $10 or more, you will get access to project files on Patreon. Now let's look at our scene. Make sure one of our terrain is placed in the 000 position, and we'll play a starting terrain tile role. Now look what happens if I add one more terrain tile and move it to the side, to exactly minus 20 position or 20 position by either x or y axis. They will exactly connect perfectly between each other. This is happening because we are using tiles with exactly the same sizes. Both of those terrains are 320 pixels in size, and both of those tiles use the same pixel per unit size. If you are making your own tiles, you should keep the sizes between each tile consistent. It can be different from my own, but you should keep size consistent and consistent pixel per unit between each of the sprite for terrain. Good, now we have those two terrains on our screen. What we want to do is to spice them up a bit, add more features. For this we will use overworld sprites. What we want to do is to slice some sprites out for us to use as decorations. To be able to do this, we need to set the overworld sprite sheet as a multiple sprite mode. So let's cut out some items for us to place on those terrain tiles. Now let's make 3x3 grid of the terrain. And now let's populate each of those terrain tile with objects we have created. To do this, first we should make those objects into the prefabs. When I put an object on the map, the very first thing you will notice that your terrain is obscuring the vision of that object. To fix this, we want to make the terrain a background, something what is always behind every other object on the scene. Select all the terrain tiles and set order in layer as -1. This way you will mark all your terrain tiles as something what should be rendered behind all other objects with higher order in layer index. So to create prefabs, put all the sprites of environment on the scene, select them and drag and drop them into the project. In my case, I put all my environment prefabs into the prefabs folder called, well, environment. Now treat each of those tiles as its own little scenes by decorating them using those prefabs we created. For obvious reason, I will not be concentrating too much on making this looks as good as possible. This is just testing and demonstration. You would have to do much more work on visual for your own game. This should suffice for now. Now if we test this, I can explore this little world by myself. But right now, not only it will not loop infinitely, we can walk into the object we placed. So to fix this, we need to add colliders to those objects. And to not go through each object individually, we can add collider to the prefab. And it will update each instance of this prefab on the scene automatically. Then add collider to the character, and this will make it so our character can collide with the environment. But we need to limit his ability to rotate, so something like this will not happen. So freeze the rotation on the rigid body 2D. Good, now we have our world. Now we want to make it infinitely loop. If we walk into the same direction for a long time, let's put all our terrain tiles into one empty object, called world. Make sure world in the 0, 0 position before beginning. So it works by simply moving the terrain tiles when the character moves away from them. Select the world container object and add and create a new component called world scrolling. Open the newly created script. Here we will control the scrolling of the world. So to understand what we're going to do, look at this. You can see character standing at the start in 0, 0 position. Because of our setup, the terrain tile bottom left point is -10, -10, and top right is 10, 10 position. So with the knowledge of the size of each tile, we can tell what tile he is currently standing in. So let's call it terrain tile position. So in the case at the start, because we are in 0, 0 position, we can easily say we are standing in 0, 0 terrain tile position. And because our character stands in this tile, we can see that in this paint representation we can see a visible area, similar to camera frustum in Unity. So tiles around the character will be visible, and when character will be moving around, we will be moving those tiles. To place the tiles which we can't see anymore to be used inside the visible area for the player. Good, let's do this. We will need to be able to reference the player transform, and let's create current tile position variable of type vector2int. And now create a 2D array for terrain tiles game object. Then create two new variables, terrain tile horizontal count and terrain tile vertical count, and use those two variables to initiate the array for terrain tiles on awake. Set those values in the editor. Because we have 3x3 tiles, set terrain tile variables as 3x3. Good. Now we need to place reference to those terrain tiles into the array of the world scrolling. Select each terrain tile and create another new component which will be called terrain tile. Inside the script, declare serialized variable called tilePosition, which will be responsible for holding the position of the terrain tile on the grid. Then in the start, get the world scrolling from the parent of this object and call and create a new method called add, where you will pass a game object of this terrain tile and its position on the grid. Inside add, assign the reference to the object into the array using the pass position. Now we want to assign the tile position for each terrain tile on the scene. Start from the bottom left tile and go from there, one by one, from 0, 0 to, end of all of those tiles. Good. Now in the world scrolling we want to determine the current position of the player. Create player tile position variable. In the update, we want to calculate the player tile position on the terrain tiles. To do this, create tile size variable. We know that each of our tile is of the size 20. And inside the update, divide the player position by the tile size. If we launch this game now, you will notice that it works, but in a weird way. This is happening because our point of origin of the tile is in the center, creating an offset equal to half the size of the tile. Bottom left of the terrain tile is -10, -10, and top right is 10, 10. So we need to change the pivot point of the terrain tiles to be bottom left. This will shift every tile to the side. So we will have to fix the parented scene objects. Select and move them into place. Good. Now in the update we want to determine if our character changed his position on terrain tiles. So when our character is moving, he's changing his position. We need to determine if his new position is inside the new tile. We already have a variable called current tile position, so compare it to the player tile position after recalculating it. If they are different, that means our character have moved to a new tile, and we need to move the terrain tiles to fill his field of vision. Now what we need to do is to determine which terrain tile to move to fill the field of vision. To do this, first we need to convert the global position into on the tile terrain grid position and take into account the repeating pattern of the terrain's tiles. So if you move horizontally, your X position on terrain grid will have values between 0 and 2, because we have 3 tiles on horizontal axis, and when you reach position 3, you loop back to the 0. So create a new variable on tile grid player position and create a new method called update on tile grid player position, which will recalculate on tile grid player position by getting the leftover of the position. This will calculate the position on the terrain tiles grid. But there will be a problem. If I walk into negative value, it will invert the values. To re-inverse the values, we need to add the leftover of the negative value to the count of the terrain tiles. Add -1 to take into account the indexation start from 0. Now we need to update the tiles on the screen. Now we want to update all the terrain tiles which will be visible inside our field of vision. So create a new variable called field of vision height and field of vision width. Make sure you never set your field of vision higher than terrain tile count. That's going to be disaster. Cycle through all the tiles inside our field of vision. Now we want to get tile out of the array. But we need to determine which tile we are supposed to use. And we need to take into account the wrapping of the terrain. Instead of creating a new method, let's actually repurpose this method. It is a good idea to reuse as much code as possible. So let's make this method into more generalized calculation of one axis value. Pass current value and bool horizontal. Then use horizontal bool value to determine are we calculating horizontal values or vertical values, and calculate the current value, similar how we used to do this with hole position. Return this current value. Actually, this current value should be a float as a parameter, and on the return we will convert it into the integer. Now we are calculating each position individually. So calculate X and Y position for the on-tile grid player position. Inside the cycle we need to calculate which tile we're going to update based on the player position and point of view. Then we get the tile, we're going to update an updated position by creating a new method called calculateTilePosition and pass the player position offset by his point of view. We're doing this because here we're placing the tile in the world space, so we will use position of the player to calculate the actual position of the tile in the world space. We're using player position as like an anchor to anchor the whole world around him. Okay, something is wrong. Oh, I know. First we need to offset the POV, so the POV will be calculating the tiles around the character, instead of starting from the position of the character. Good, but there is definitely some problems with calculating position in the negative values. Let's remove this -1. Oh. Okay, that is a good time to discuss how to debug problems like this. When your interaction with error return errors like this, we want to determine which values are causing this out of bounds error. In our case, we're interacting with the error using only tile to update X and Y. So let's put them into the debug log and see. So we can clearly see that there is an issue with calculation of negative values. First problem. I forgot to set this bool to false. This is why you need to be very careful while copy pasting the code. Second, in the update we need to offset the player tile position by 1 if he is entering the negative value. I will explain this in details in a little. And to take into account this offset, we need to add 1 to the value in the calculations of negative values. Let's test this. Okay, as you can see this is working, so why do we need to do this in the first place? Well, the explanation is pretty simple. Take a look at this. In the center we have a 0, 0 position, and we have 4 possible positions where our character can stand. So let's begin with top right one. Let's calculate his position on tile grid. Divide 8 and 4 by the tile size of the terrain tile. In our case it is 20, so we get 0, 0 position. Let's say our dude crosses the 0 line and stand in -1, 4 position. Let's calculate his terrain tile position. It will be once again 0, 0. No matter where your character stand, before his position exceed 20 as a number, he will always be in the 0, 0 position, and this is why our tiles were acting weird. And this system should be easily expandable. Just create a new line of the terrain tiles, set them up, and it should work just like that. Now I want to clean up the screen on the game start and show all the visible tiles. And in the world scrolling on the start, call update tiles. To ensure that our tiles will be added to the array before the start in world scrolling is called, we want to set the order of the execution of those tiles before the default time. Good. Let's clean up this debug message and we are done. There is still place to clean this code up and some optimization, because right now we are repositioning all the tiles on the scene every time we are moving, which is not necessary, but this episode ran for long enough. Good, this is it for this episode. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. Special thank you to Andrew V. Long and This Old Hashdo for their generous support. With best regards, see you in the next episode.